As we start chapter 5, these are the ones that are particularly important to our background as we prepare for the next math course, giving you the terminology of algebra and preparing you with the skills for mastery. So hopefully you do well in these sections. So here we're going to be simplifying and evaluating algebraic expressions. We will evaluate algebraic expressions by combining like terms and, of course, building lots of vocabulary words, and then evaluating expressions for giving values of the variables. We did a little bit of this earlier in the course. Now, as we look at these down here, x, a to the third, a negative x, a negative a y to the fifth. Now, when we look at, to give a little background, if we have something like this, first of all, what is a term? And you want to take some notes on this. Well, by definition, a term in an algebraic expression is separated by either a plus or a minus sign. So one thing we might ask, how many terms are here? Well, this is one term, this is one term, this is one term, and this is one term. So in this expression, there are 4 terms. Now, when we think of the term, let's say 2x to the third, there are parts of this term. For instance, the letter we refer to as the variable because we don't know what value that is. And then we have usually a numerical coefficient in front of the variable. So here the numerical coefficient is 2 and the variable part is x to the third. Now, when we see this value here, if this were the term, there is no number in front that's visible. And that's because by convention, when there is no number, there's actually a 1 there. And that's what they're showing. So the numerical coefficient of this x term is a 1. And a to the third, again, there's no numerical coefficient. There would be a 1 there. And that would be a 1. Now, when we have a negative x, and again, if it's positive, we say for the leading term, you don't have to write the plus sign. But if the leading term is a negative, you have to put the negative to indicate that. But what would be the numerical coefficient part? And there's our word, by the way. And the answer is a 1. And that would be a negative 1. And the same would apply here. There is a 1 that we don't write, and that would be a negative 1. It would include the negative sign. Now in this next part, they're going over what they call like terms. And again, we've defined what a term is. It's something in an expression that's separated by either a positive sign or a negative sign. But to be a like term, and this would only apply to the variable part, if the letter of the variable and the exponent on that variable is the same, then they are like terms. So as we look at this one, we see a b, and if there's no exponent, we can think of a 1 being there. So this b, even though it's been switched around through the commutative property that we mentioned a little bit earlier, this would still be good. B to the first, a to the second is the same. So these would be like terms. Now, when we go here and see a to the second b and b to the second a, notice the a is squared, but here the b is squared. So these are not like terms. But if we switch the order of these last two, a to the first, b to the second, these would be like terms. Now, when we combine like terms, the only part we deal with is the numerical coefficient in front. The variable part, when we're adding and subtracting, that is combining like terms, stays the same. Now, another important vocabulary word is to look at what is called the degree of a term. So here I've listed 4 terms. By definition, and again, this only applies to the variables. If there was a number in front, like 2 to the third, we wouldn't consider that 2 to the third, the numerical part, as part of the degree. The degree only applies to the variable part. So what would be the degree of this term? Well, you add up the exponents on the variable. Well, here, there's a 2. So the degree then of this would be a 2. Now for this one, we have a 2 and a 3. Adding up the exponents on the variable, this one would be a 5. Now, if there is no exponent showing, then there is a 1 there. So this one would be 6. And here, this is, of course, just a 5. Now, a little later, they're going to ask what is the degree of the expression. And if we just put pluses between all of these, this then becomes an expression. And the degree of an expression is a little bit tricky, because you would think you would add all these up, and that's not true. The degree of the expression, by definition, is the highest degree of any term. So as we look at these 4 degrees, the highest one is 6. So if this were an expression, the degree of the expression would be 6. The degree of a term is the sum of the exponents on the variable. Again, you want to take good notes. I see lots of quiz questions here. Our first example, and as you put these in your notes, you should be writing down example 1 of our PowerPoint slides. Like terms. Pick out the like terms here. Well, we have an, let's see, so the like terms would be the -7, this one, the ones with just a single x, and then these would be like terms as well. And the 0, in a sense, would go along with just the numerical part. And these were the constants, so those were like terms. And then those variables with just the x, they would be like terms. And then if the exponents on the variables and the variables are the same, these are like terms as well. Now, when we combine like terms, that is, we're going to add them or subtract them, as we mentioned a few moments ago, we only deal with the coefficients. The variables stay the same. So, we're only going to deal with the 8 and the 10. So this will be 18x. Now they're showing you in the solution that you could factor out the 8 and the 10 like so. And then that gives you 18. Normally we do this part in the parentheses mentally. So again, we're only going to subtract the negative 2.3 from the 6.5, and we get the answer 4.2. And again, you could do that mentally, or you could write it out. Now here, part of it is to recognize what are the like terms. And one of the techniques we suggest to students is rearrange this, put all the like terms together, as they're doing here. Well, not yet. There they are. So we got a 2 and a 1, x squared, that's going to give us a 3. And then when there's a 1 there that we're going to take away from the 3, that will give us 2a. And we see that in some detail. Now again, you can do this part mentally, or if you want to write it out like this, that would be fine. Now, for combining like terms in example 2D here, what we need to do is get rid of the parentheses, and we're going to use that distributive principle, where this becomes 4 times n is 4n, 4 times a negative 7 is a negative 28, this becomes 5n, multiplying the 5 by the 1, get 5. So you have this. Now once you've gotten rid of the parentheses, you now can rearrange or mentally. 4 and a 5 gives me a 9n, and then subtracting 5 from the 28, but keeping the negative sign, this is going to be a negative 23. And I like the use in these PowerPoint slides of the rules that are applying here. Now, a lot of these rules were done in parts of Chapter 1 that we didn't cover, but we did go over the word commutative, and we've gone over distributive now, and associative as well. And there's our final answer. Okay, now we want to combine like terms here. So the fraction bar, as we mentioned earlier, serves as a grouping symbol. So we have x plus 3x. This will give, remember there's a 1 in front of that x, a 4x that they're showing here, over 2. Now we can do some canceling. 2 goes into 2 once, 2 goes into 4 twice. So this is going to end up being 2x when we do this division. And now we have like terms that we will combine, and we get 7x. Notice they're skipping that middle step now, which often we don't use, but do that part mentally, knowing we only deal with the numerical coefficients. The variables stay the same. Now in this next part, we're going to evaluate algebraic expressions. We combine like terms if we can, then we substitute the values they're giving us for any variable, and then we follow the rules for order of operations that we went over in Chapter 1. So here, they're saying evaluate if x is 3. So 3 squared will be 9. Now how about if x is a negative 4? Well, negative 4 squared is negative 4 times negative 4, a positive 16. And there's our 9. And these are the steps. Now remember, if we're going a tad fast, pause, take your notes. This is your background and maybe something that's on a quiz. And then, keeping in mind, when we substitute the negative 4 for the x, we put it in parentheses, because the negative is part of what we're going to square. Negative 4 times negative 4. Or the rule in which we said, if they have a negative value, that we're raising it to an even power, that's going to give us a positive. So, little rules as we move along. Now, notice the difference here. This was just x squared. Now this is a negative x squared. And the key is, when we substitute for the x as a 3, watch this, the negative is not included as part of the x. It's just the 3 that we put as a replacement for the x. Now we do the squaring. 3 times 3 is 9, which is they're showing. There's a negative sign in front. We could put a 1 there, as that's what they're doing. So we now have negative 1 times 9 is negative 9. So notice the difference between what's up here and what's down there. The negative sign is not included in what we're squaring. Now, when we put the negative 4 in the parentheses, as they show here, we square that and we get a positive 16, but then we apply the multiplication negative 1 times 16 gives us a negative 16. These are areas where students often mess up a little, but I like the way they've laid this out, something you should have in your notes. Okay, now they're giving us an expression. There's 3 terms, but we see 2 of them are like terms. So we want to combine the like terms first. This will give us a 9x plus 5. And once we do that, we now want to substitute for the x a negative 3. So where the x is, we carefully put the negative 3. And I suggest parentheses. I like this. So 9 times negative 3 will give us a negative 27 plus 5, and mentally negative 22. There we go. Pause it as needed. Okay, so we're looking at this. Can you see you're going to combine some like terms, and once you do, you're going to substitute these values. So we have 3ab minus 4ab will give us a negative 1ab. We don't usually write the 1. And this is going to be a negative 1a from this is positive 5a. Okay. Now we're going to substitute. And carefully, for the a, we're going to put a 2, which is what they have here, and the b, this b, a negative 1. Now notice what happens here. Negative times this negative will give us a positive, and this is going to end up as a positive 2. And this, when we substituted our a here for this, we get a 10. So 2 plus 10 is a 12. Well done. Again, we're going to simplify. The division bar serves as a grouping symbol. 5x plus 3x is 8x divided by 4. Then we have to distribute the 2x plus 1. And I guess I have some emails coming in there. So let's do that. So combining our like terms, we get this over 4. Distributing the 2, we get 2x plus 2. Now notice we're going to do division next. 4 goes into 8 twice. So that gives us then a 2x here plus 2x will be 4x plus 2. There it is. I like the way they're doing this. And now we're going to substitute. So we're saying x is 5. Where the x is, we put a 5 in parentheses. Now we do the multiplication first. 5 times 4 is 20, plus 2 is 22. Well done. Now, here are some practice problems that we're going to pause here for a moment, and we're going to let you work them out. Now, physically pause the tape and then see what you get for your answers. And we'll do this in parts here. Then we'll do the last one. So again, we only deal with the numerical coefficients, -2, -5, -7. Here we have to combine like terms. There's a positive 12y and a negative 1y gives us a positive 11y. 6 and 10 are 16. Here we have to distribute. We get 5x minus 5 plus 4x. Combining our like terms, 5 and 4 is 9x minus 5. Here we're grouping like terms, 2b squared, 1b squared, 3b squared. Now a negative a and a positive a just cancel out, and our 0 that we don't write. So if you haven't done it, you're going to distribute, combine like terms, and then evaluate. So we're going to go 2x plus 6y right there, 4x minus 4y. Now we combine our like terms. 2x and 4x is 6x. And then 6y minus 4y is 2y. We substitute the x with a 3. That gives us an 18. The y with a -2, that gives us a -4. This gives us a 14. So hopefully you have this done. And now we get to see what this looks like a little bit on our next slide as they give us the answers. And again, pause here, but this will wind this up.